Hello, welcome to Psych 319, Chapter 8, Part 1. This is all going to be about consciousness, and I'm going to, as a change of pace, I'm going to do less talking and more asking of questions to get you to start thinking about consciousness. And this really all in my life started when um, I was taking a seminar as a graduate student, and a bunch of papers came out on blind sight. And blind sight is the phenomenon where a person believes that they are totally blind, but if you put them in front of a computer monitor and you ask them to do some vision detection tasks, they end up performing better than chance, which means they can see, but they don't have the belief that they can see. And so the thing about blind sight is those patients have damage to primary visual cortex. So a lot of the people in the room in that seminar believed, and some of the papers were proposing, that primary visual cortex was the seat of consciousness, where consciousness existed. And we deliberated this question for a couple of weeks, and we came to the conclusion that primary visual cortex is not the place where consciousness exists, but it might be necessary and sufficient in order to sustain a conscious representation of vision. So remember, the brain is an incredibly elaborate network, so it's hard to say that consciousness exists in any one location, but that it is rather every part of the brain contributes in some way to consciousness. So consciousness is the emergent property of your entire brain working in coordination at the same time. That being said, we're going to go through a number of theories, um, define consciousness, do a little history, the functions, states, models, and processes involved. So consciousness is very much a subjective experience. We believe we are conscious, unless you have brain damage like in blind sight. It involves the awareness of things, and that awareness can be altered via external or internal stimuli, drugs or sleep or lack of sleep or attention or your general state of alertness and arousal. Um, and there are several models to describe this. It's a very difficult problem because, like I mentioned, it involves all of the brain. So it's difficult to study the entire brain all at once. And we're getting some clues with neuroimaging, because neuroimaging does allow you to look at the entire brain all at once, but it doesn't have the spatial resolution to allow you to look at every neuron all at once. So we have a lot of work to do. I'm going to skip briefly over a lot of this information here, but remember, the history of consciousness has evolved over time from being the idea that consciousness was attributed to a single gland, all the way to the idea that consciousness is a network like a computer. Again, I'm going to skip over some of this history. It's all in your text. So yeah, I guess I mentioned this computer idea where that your brain can be modeled as a neural network, and that if you can somehow get a machine to demonstrate properties of consciousness in this neural network, then it might give us a clue for how the brain represents information and how consciousness emerges from a group of neurons acting together. And so there's several models. The awareness model here says there's a bunch of aspects of consciousness that contribute to and define consciousness, so you don't break it down into just saying we are either conscious or not, but you can break it down into a bunch of sub-processes like attention, wakefulness, the design of the brain, the ability to recall information, emotion, the ability to orient to novelty, and all of these individual properties, which again are defined better in your book, contribute to this idea of that, well, maybe we can get a more restrict definition of what consciousness is and what it isn't. And to define what it isn't, they propose this idea of the zombie, which you're all familiar with in movies, video games, and so on and so forth. But the idea of a zombie is, well, imagine a being that has all the functions it needs to survive but lacks consciousness. How would it work? How would it be able to perceive objects? How would it be able to do all of the processes we've talked about up until this point? And so it poses an interesting question, and I'm not going to give you an answer to this, but do you think that a zombie could exist? Do you think that it's possible to be able to perceive objects without attention, for example, after having learned what you know about attention? And if not, then what does that say about attention's role in consciousness? A little subterm here called qualia. Qualia are subjective experiences associated with the properties of sensory experiences. So qualia is kind of a loosey-goosey term for the idea that you have your own perceptual experience associated with a stimulus. If I show a red apple to you and to your sister, you might have a different subjective experience of that because you have different sensory experiences, and therefore you have different consciousnesses. But anyway, so the functions, I think, are very intuitive. They allow us to interact with the environment, and there's more strict and refined definitions about this, allowing us, for example, to prioritize and access information in a particular way, allowing us to access information that was maybe previously unconscious information, perhaps like in our example with sensations and perceptions. Perhaps there are sensations that you are unaware of until you allocate attention to it, you prioritize it, and then it becomes part of your consciousness. So now you can think, well, maybe attention and short-term memory are very, very important. If you direct your attention to something, then it enters into your awareness via short-term memory. You're allowed to rehearse that concept. When I bring up the concept of a cow playing soccer, now you have an image of your head of a cow and a soccer ball doing something very, very bizarre and unnatural, but that is, those two unconscious concepts have now entered into your conscious awareness because I've directed your attention to that. Other properties that are very important: decision making. It's impossible to make unconscious decisions. We might have unconscious behaviors that might be sort of stimulus-response reflexes, but those aren't actually decisions. They're more like reflexes. Et cetera, et cetera. Again, so all of these things are very much defined in your book. I would like to talk a little bit about sleep and altered states of consciousness, because that speaks a little about what it means to be conscious when we talk about how that consciousness can be altered. So when we look at sleep, we are using electroencephalograms to measure the total brain state, and EEG allows you to measure electrical potentials through the scalp, and it's great because it allows you to look at the millisecond resolution timing of what the brain is doing. Its major weaknesses is it's very bad at pinpointing where things are going on in the brain. But through our studies of sleep, we've learned that when we go to sleep, the brain tends to cycle all at once. Unlike when it's awake, when your brain is awake, it's doing a million things at a million times, but when you go to sleep, it tends to operate in synchrony, and that can be reflected in the brain waves. So the whole brain is working in concert in that particular way. And of course, we know from our own experience that consciousness is greatly altered during sleep. We have a very different subjective experience of the world, and in fact, we're cut off from most external stimuli, so it's indeed a very much an internal representation. So there are several stages to sleep. When you're awake, the brain demonstrates alpha waves. I'll show you these in a while. These are very easy to identify. And then the second you close your eyes, your brain changes its pattern of activity. You wouldn't even call it sleep. We call it stage 1 sleep. But the idea is that you're just starting to doze off. Your brain wave immediately changes its activities due to the lack of visual input. And then somewhere around stage 2, you see sleep spindles. Stage 3, we get delta waves. Stage 4, deep sleep. And then we get into REM. And the interesting thing about REM is you can see here the waves. REM sleep, the brain waves, look very much like you're awake. And REM is where we have most of our dreams. It's called rapid eye movement sleep. So when you're dreaming, your eyes are moving around really, really quickly. And it's as though you're looking at some type of image going on a movie screen or something. So let's walk through these again. So you're awake. You have these very quick, jerky, low amplitude, and very erratic waveforms. The second you close your eyes, you enter in this alpha stage, and you start to see some periodicity in the waveforms. And then we slip into stage 1 sleep. We start to see a slight emergence of theta waves, which eventually, these are about 30 hertz. Theta is, they mean, when they say theta, they mean about 30 times per second. And then you get to stage 2, you start to have a real emergence of theta waves. Compare the size of these waves to the alpha waves up here. You can see that these are much larger, and there's more periodicity. Then you see two things emerge: sleep spindles, very short bursts of activity, and K complexes, very large waveforms. These K complexes eventually give way to delta wave sleep. So now look at the brain is entirely different here. We have very large, low frequency waveforms. The whole brain is cycling in synchrony here in delta wave sleep. What's going on here? We don't know exactly. We do know that dreaming tends to happen mostly in REM sleep. So there's a thought that a lot of brain restoration and grouping of and strengthening and weakening of connections is going on, mostly at this stage, but indeed at all stages. The idea of the modern conception of what sleep is for is that it's for building connections that you use and getting rid of and weakening connections you don't use. So all those faces on the train that you may have seen this morning, most of them you are going to want to forget. And so what this type of sleep helps you do is it helps you consolidate the faces you want to remember in life and get rid of those that you don't need. And that's thought to be the main purpose of sleep. Of course, our consciousness is very, very dramatically altered. I'm not going to get too much into sleep and dreaming because I could teach an entire course on that. There's various states of dreaming. Let's get to the more interesting stuff here. So when we dream, what's going on is we're getting spontaneous activity throughout the brain. And some of that activity occurs at a very low level. It starts at the brain stem, it starts at primary visual cortex, and an organ called the pons in the brain. And when these areas start to fire, they create spontaneous spontaneous activity that is interpreted by the rest of the brain as having some kind of meaning. So imagine that I just put an electrode in your brain and just randomly fire it off. That's going to get some memories to spark off, and it's going to bring some memories into conscious awareness. Now what's interesting about dreaming is we're taking all this spontaneous activity and we tend to try and interpret it. We create storylines and assign meaning and emotions to things, but it's really actually quite random activity going on in our brainstem. The brainstem is just pumping out juice to help bind all these memories that are important together, and as a result, the higher order parts of our brain are interpreting this random activity as part of a storyline. And so we assign all this meaning and interpreting dreams and so on and so forth. But it's really quite random. Lucid dreaming is the idea that a person can control their dreams. They are in a weird state where they, and you might have had this every once in a while, but lucid dreamers have this every night, or most nights. They can exert cognitive control of their dreams. They can direct the storyline of their dreams. It's considered a sleep disorder, but it also tells us a lot about how and why we dream. Okay, I'm going to stop here before we go into the next section, and I'll see you next slide.